Fusion Mobile, quality e-learning experience on the go.
Welcome to Fusion Mobile e-learning clinic. My name is Sonia Lalo and I'll be guiding you through the chemistry course. In this particular lesson, we're going to look at the electrode potential, electrochemical series, and electrolysis. Electrode potential, electrochemical series, and electrolysis. To begin, we'll consider electrode potential, then we'll look at electrochemical cells, and then we'll go to electrochemical series. And we'll also consider electric charges and current before we'll talk about electrolysis. Then we'll look at the methods, the mechanism of electrolysis, and then we'll consider the Faraday's law of electrolysis and conclude the lesson with the uses of electrolysis. So, let's begin. Let's talk about electrode potential. Of course, when we hear the word potential, it talks about energy, energy stored, energy available to do some certain kind of work. If you have a particular system of, say, a particular metal, and the aqueous form, the aqueous form of the salt of that particular metal, as the salt of that metal dissolved in the solution, you would have a system where there is a possibility of two different reactions occurring. Let's say metal is M and it is univalent. There is a possibility of two things occurring. The first thing is that this M would give off electrons and then it will give out electrons, and then it will become M will give out electron and it will become positively charged, or the reverse situation. It can actually accept electrons that's from the aqueous salt and become neutral charged. This is more likely to happen at the bar of the metal that is used in the system. That's a plate. That plate is described as the electrode. The plate which you insert into the system is regarded as the electrode, while the aqueous salt, that is a solution which contains the ions of the particular metal, is regarded as the electrolyte. So, at the electrode, this is more likely to happen since the metal is plain metal in the pure form. So this is likely that it would lose electrons, and also the salt is likely to decompose and gain electrons and become stable. So depending on what happens and at which place. So if the metal is actually gaining electron and it becomes we have more of this, and if it's actually losing, we have more of this. So when it is gaining, we have a positive charge at the electrode and a negative charge in the solution. And when it is losing, actually we have a positive charge in the solution and a negative charge at the electrode. So it would always find a way to occur. Now, this particular system also leads to a creation of a potential difference, and this potential difference is what we regard as electrode potential. On your screen just about now, you have the definition for electrode potential clearly written. So we have the definition for standard electrode potential of ions. So the overall energy involved in the entire system is what creates this standard electrode potential. Now, this electrode potential vary based on the elements that is in question. Of course, I also have a chart containing a table containing a list of some of the elements, metals. We have potassium having the highest, should I call it lowest now? That's minus 2.92, and we have gold at the bottom of the list with plus 1.68. So in the electrode potential, basically what we see is transfer of energy from one place to another. Actually, it's transfer of electrons. Electrons move. But when we also now look at the electrochemical cells, just from the name, it means that electricity and chemicals, that's electrochemical. So it suggests that electricity is being created from chemicals. Now, if you have a system containing a perforated wall, and you have in one side of the perforated wall, you have your copper sulfate, and the other side you have zinc sulfate, and you have your copper rod here. Of course, we know that our copper rod would induce the creation of the release of electrons in that side, and we have our zinc rod here also. This zinc plate. This one will also induce the creation of electron. If you connect them together and you check, you discover that there is electric voltage passing through. Electric current would actually pass through because the electron lost on one side is being gained at the other side, and there will be excess electrons still available. So this excess electron can carry electric charges from one point to another, and we know electric current is simply charges in motion, electric charges in motion. So we have a lot of different cells that are designed using this particular mechanism. Some of the cells include, we have about 3 different examples on the board. We have the Daniel cell, we have the Leclanche cell, and the lead accumulators. Now in the Daniel cell, that's the one we have been discussing earlier, we have the copper tetrahydrosulfate 6 and the zinc tetrahydrosulfate 6. Inside the copper tetrahydrosulfate 6, we have a copper metal, a copper, that's the anode, the cathode. So it has a copper casing to make contact with it, while the anode is a zinc rod that enters into the zinc tetrahydrosulfate 6. A picture of what the setup looks like would be displayed on your screen about now. So we have the electrolytic process going on. It's an electrolytic process, and it's also a power generation process. Also, when we consider the Leclanche cell, we have the zinc tetrahydrosulfate 6, and we have the ammonium chloride. We have a zinc rod being used and a carbon rod being used as well. The zinc rod serves as the anode, and the carbon serves as the cathode. So the reaction also occurs. Oxidation reduction reaction takes place. Of course, we know that at the anode there is always oxidation, and at the cathode there is always reduction. So ammonia gas is given up, and zinc is being oxidized, and that's how the energy is being created, the electricity is being created. Also in the lead accumulator, now the lead accumulator is a rechargeable system. It's a rechargeable system, that is, it can accommodate electricity to charge it up, and it also gives out electricity. It is commonly found in those rechargeable lamps. Rechargeable lamps. So what is it made of? It contains an electrolyte, that's lead tetrahydrosulfate 6 dilute form. We also have the anode, which is made of lead, and the cathode, which is made of lead 4 oxide. So the oxidation reduction reaction also occurs in the system to lead to the generation of electricity. Alright, before we go any further, we're going to take a short break about this time to test what you have understood in this lesson so far. Please, in a few seconds, some questions will be displayed on your screen. Please answer them, and let's know what you've learned so far. So welcome back. We've looked at the electrode potential and electrochemical cells. Now let's talk about electrochemical series. When we talk about electrochemical series, it simply has to do with the arrangement of elements based on their electrode potential. It doesn't necessarily have to be elements, can be compounds as well, because certain compounds are actually more reactive than others. So in the we have the metals like potassium coming at the top because of their high electronegativity. positivity, their high electropositivity. So they have the high reducing agents. They come first in the electrochemical series, while the high oxidizing agents are at the bottom of the electrochemical series. So we end up having something like potassium at the topmost top, and we end up having fluorine at the bottommost bottom, if there is any such thing as that. Potassium leads the pack, while fluorine is at the base of the entire troop. In this electrochemical series actually help us to understand how substances do react in electrolysis, how they react in electrolysis. So let's talk about electric charges and electric currents. Electric charge is simply the movement of electric electrons within a particular system. A system can be charged up, a system can be discharged. Of course, we all know, we all did this when we were much younger. We take our biro with the plastic cover, we rub it on our hair, and then we tear a very tiny piece of paper, and we move the paper, move our biro close to the paper, and then we see the paper kind of like move, like it is being magnetized by the rubbed biro cover. What we see there is simply the action of electric charge. The action of electric charge, it creates a kind of force. Now, the paper has been charged up. The cover, the biro cover has been charged up. So it attracts the positively charged paper. It is negatively charged, so it attracts the positively charged paper. Of course, different materials do react in this. Also, if you have silk and you rub silk around a glass rod, it creates something identical to this kind of system. So, when we talk about electric currents, what we mean by electric current is simply charge in motion. Current is simply charge in motion. That is, this charge are in continuous motion. So, we calculate charge in coulombs, we calculate electric current in ampere, and 1 ampere equal to 1 coulomb per second. 1 ampere equal to 1 coulomb per second. So, in our batteries, what we have are chemicals. Now, each of the chemicals, these chemicals release charges, electrons, into the system, and that is how electricity is being generated. So, our electric current is simply our charge in motion. Now, these are some of the ways in which we source electricity. Electricity can be created via a couple of means: electromagnetic induction, chemical means, which are found in batteries. Of course, how is electricity transmitted? Electricity is transmitted through metals via conduction. Of course, the electrons are being displaced. They get in motion, and then they transmit the electric current from one side of the rod to the other end. So that's how we come about the idea of conductors and insulators. Insulators generally do not allow electricity to flow through them. Conductors allow electricity to flow through them. Now, what is the chemistry behind these working principles? Insulators have their outermost electrons kind of filled, more stacked. So they do not have valence electrons that could actually move so frequently, so freely. But the metals, which have actually a few valence electrons, do have a greater degree of freedom. So the electrons kind of move faster and take whatever thing is needed to be taken there. That's the electric current, transmit it from one point to the other. So that's how conductors and insulators operate. Alright, let's look at electrolysis. Alright, before we go deeper into electrolysis, let's take a few definitions in electrolysis. In a few seconds, the definitions that I want to introduce to you will be displayed on the screen. Alright, there it is. The first thing to describe is electrolysis. Electrolysis is simply the chemical decomposition of a substance by use of direct current passing through the substance or through a compound of the molten form of that particular compound. We also have the electrolytes. Electrolytes are the compounds that the electricity is being passed through. The electrodes are the conductors in form of wires, rods, or plates, which are used to convey the electricity into the system. The anode, of course, that's the positive electrode, while that's where the electrons leave the electrolyte, while also is also the positive terminal charge of electric source, while the cathode is the point where electricity enters into the electrolyte, and it is the negative source of electricity. So basically, we have the system, you have your electrolytes, that is the liquid or the molten substance which are about to undergo electrolysis. We have the electrodes, which are the two bars or sometimes plates. One of them is described as the cathode, that's where electric current enters into the system, and the other one is described as the anode, that's the positive terminal of the electric current. So on the functionality, the operation of before we go to the mechanism, we have to understand certain principles. One of the principles we have to understand is the ionic theory. In the ionic theory, we're made to understand that all substances contain ions, atoms, and these atoms can be simplified, can be broken down into ions when they have the opportunity. Every particular atom is trying to be stable. So at that ionic state, they attain a certain degree of stability. So naturally, if you are passing electricity through a particular system like the one shown on the screen about now, you see that the system, the components try to break down into ions. We also have what we describe as electrolytes and non-electrolytes. Electrolytes are substances which, when we pass electricity through, they decompose, or they allow the flow of electricity changing their structure, while non-electrolytes either do not allow the flow of electricity completely or do not change their particular composition. Let's look at the mechanism of electrolysis. On your screen about now, you have a particular description, that's a setup of an electrolytic system. And if you can look at it, you have the cathode, the anode, the electric supply, and the electrolytes, everything. Now, if you observe, you know that from all we have been learning today, we observe that the process which electrolysis occur is actually a redox reaction, oxidation reduction. And as we've been saying earlier, the oxidation occurs at the anode, the reduction occurs at the cathode. We also have certain materials, certain substances, the way in which that's why we talked about the electrochemical series, the way in which the reactions do occur, how sensitive to this electricity are these particular substances. Of course, on your screen about now, you have the electrochemical series for relative positions of ions. We have potassium at the top, of those which have the increased preference for discharging, and of course that is at the cathode. At the cathode, we have potassium at the top, we have gold at the bottom, those because they are cations. And why are they called cations? They are called cations because they are attracted to the cathode. They are described as cathode ions, while the ones that are attracted to the anode are described as anode ions. Hence we call them anions. So the electrochemical series shows increase how sensitive to the cathode they are and how sensitive to the anode they are. Of course, this entire system leads to production of energy. It leads to production of energy. Energy oftentimes accompanied by a dissociation of certain materials. Okay, let's look at the Faraday's law of electrolysis. Michael Faraday conducted several electrolytic experiments, and he came up with a couple of laws, two of them. You have on your screen about now the first law of Faraday, which says that the mass of elements discharged is proportional to the amount of electric current that is passed through it and the time, of course. So what he's saying is this: the quantity of electricity is directly proportional to the mass, and there's also a constant. There is a constant K, which is actually Z. That constant Z is the sensitivity, is the reactability of the substance. So now Q is also the same thing as IT. Q is the quantity of electricity, and it is amount of current multiplied by the time. So we have the M equals ZIT as given by Faraday as the first law. It's the second law of Faraday states that when the same quantity of electricity is passed across a different electrolyte, the relative molecular mass, or rather the relative number of molecules of the element discharged, is directly proportional to the ions of the system. So Faraday actually was just trying to prove to us that there is a consistency when it comes to this particular thing. So in that particular one, we say that M1 over M2 equals C1 over C2. So where the C, of course, is our Z from 1 here. So what are the uses of electrolysis? What are the uses of electrolysis? Electrolysis finds a couple of uses in our day-to-day life. It is used for production of electricity. It is used for it is used in the extraction of certain metals, especially in the laboratory. Extraction of certain metals from their salts. We go through electrolytic process. That's the way we can get some metals in their pure state. It is also used in the electroplating of certain materials. Probably you want to electroplate your iron, you want to electroplate your, of course, electroplating has a way of helping out. It prevents rusting. If you are electroplating with a rust-proof material, of course, it makes you be able to get something that is expensive at a relatively cheaper price. So that's the concept of electroplating. And apart from purification of materials and electroplating, we also see the use of electrolysis in dissociation of certain compounds, production of certain compounds. If we need, there are certain compounds that cannot be created, that cannot exist in their natural state unless they are passed through the process of electrolysis. All right. In this particular lesson on electropotential, electrochemical series, and electrolysis, we talked about electropotential, we talked about electrochemical cells, electrochemical series, electric charges, currents, and also we talked about electrolysis. We talked about the mechanism of operation of electrolysis, and then we looked at the Faraday's laws, the two laws of Faraday, and then we talked about the uses of electrolysis. In a few seconds, some questions will be displayed on your screen to test your understanding of what has been taught in this lesson. Please do well by answering them. And if there is any part of this lesson or the question that is proven to be difficult, you can go over the video one more time for better clarification. Thank you.